Topic of discussion is to derive the expression for the excess pressure, that is pressure difference inside the drop and the bubble. Now see, a gas bubble in liquid is shown in the figure, that is figure number A, and figure B is showing that this bubble is spherical, and in C the soap bubble is shown in the air. Okay, so figure C is showing you the bubble which is made here, or we can say in the air. So soap bubble is in air. Suppose bubble formed by this way, radius of this bubble is r. Okay, inside pressure is pi, so pressure inside is pi, and here the pressure outside is po. Okay, so pi minus po will be the pressure difference that we want to calculate, because inside pressure will be always more. Now when bubble of radius r is made, then its area, or we can say surface area, will be equal to 4 pi r square. Now when it is increased by a radius of delta r, the new radius becomes r plus delta r. So new area will be 4 pi r plus delta r whole square, and if you simplify, or you just open the bracket, then we will have the 4 pi, and it becomes r square plus 2r delta r plus delta r square. Now delta r is very small, so square of it will be very small. So just neglecting it, so now you are having r square plus 2r delta r. Okay. Now change in area we find. Okay. Change in area is a2 minus a1. So 4 pi r square plus 2r delta r, because last term delta r square we have neglected, minus 4 pi r square. So if you just simplify, then you will have 4 pi 2r into delta r, so it becomes 8 pi r delta r, that is delta A. Okay, so delta A is nothing but 8 pi, this is delta A. Delta A is 8 pi r delta r. So as you know that work done is surface tension into delta A. Okay, so surface tension is defined as work done, rather energy, upon change in area. So it becomes W is equal to S, liquid air interface. Okay, so liquid is in contact with air when it is in the bubble is formed in the air. So surface tension of liquid with respect to air and into delta A. So SLA 8 pi r delta r. Now the process of blowing the bubble, the force due to pressure difference Pi minus Po on the inside the surface, or rather pressure difference is Pi minus Po, and area is 4 pi r square. So as you know that force upon area gives you pressure. So F is equal to pressure multiplied by area. Here we have to take pressure difference, so it is Pi minus Po into 4 pi r square. So work done is force into displacement. Now work done is nothing but force multiplied by displacement. Force is how much? Pi minus Po into 4 pi r square. Displacement is equal to delta r. You are blowing the bubble by increasing the radius by delta r. Okay. So to work done we have, that is surface tension into 8 pi r delta r, that we have calculated here earlier. Okay, work done is 8 pi r delta r into surface tension. Okay, and this we have calculated just now, that is Pi minus Po into 4 pi r square delta r. So this, if you simplify, then Pi minus Po is equal to 2 times surface tension upon radius you will have. Now bubble in liquid and drop of liquid has one surface only. Okay, has only one surface or one free surface. For them equation of pressure. So whenever the bubble is in liquid, or when you have a drop of liquid in air, then it has only one surface. Try to understand, it has only one surface. And if you have say bubble in air, okay, then inside and outside there are two surfaces, and the pressure difference will be Pi minus Pu, that is equal to 4 times surface tension into upon radius. Because what will happen if there are two surfaces, then this change in area, try to understand, this change in area which we had calculated here, that is delta A, and delta A is nothing but 8 pi r delta r. This, instead of 8 pi r delta r, we have to multiply this by 2 because it has two surfaces when the bubble is in air. Okay, so it becomes 16 pi r delta r, and if you substitute that 16 pi r delta r here in this particular equation, okay, here instead of 8 pi r delta r you write 16, then here instead of 2 you will have 4 times surface tension upon radius r. Okay, from this it can be said that the for the drop of bubble Pi minus Pu, that is pressure difference, is inversely proportional to radius. Okay. Now we talk about capillary action. We derive the formula for the rise of liquid in capillary tube immersed vertically in the liquid. Now see, here a tube is immersed in the liquid, it is kept vertically. Okay, this is the tube, and the liquid rises in it and make a concave surface. Okay, and its picture that is clearly shown that this way it has been a concave surface. Okay, now this is the angle of contact. Okay, that is say theta. Try to understand this figure. This is angle of contact. Okay, this is the radius of capillary, that is A, and if you complete this whole meniscus this way, then its radius is nothing but r. Okay, so this circle which I have shown with the dotted line, that is completely made by the meniscus. Okay, that radius is r. Okay, now this way the angle theta is the contact angle or angle of contact. Now these are two perpendicular lines, you can see. So if this is theta, then this becomes 90 minus theta. So this angle is 90 minus theta. Now try to understand this angle we have obtained, that is 90 minus theta. Okay, this angle. Now this tangent and the radius, they are always perpendicular. So this angle is 90. Okay, so this particular angle as such is 90 minus theta. So this angle as shown here is theta. Okay, so angle theta, I have explained how this angle becomes theta. Okay, now capillary is placed vertically upward, liquid rises up, and that height of liquid is h. Okay, now we want to derive the equation. Now see, there is only one surface which is this with this meniscus is having. Meniscus has only one surface. Try to understand. Here there is liquid. Here pressure outside, and there pressure inside. Okay, so the pressure difference between these two surfaces, or rather this surface, you can see that pressure difference is Pi minus Pu, that is 2s upon r. We have written 2s upon r because it has only one surface. Now from the figure you can take cos theta is equal to a upon r. You can see that here if you take the cos theta, then cos theta is adjacent upon hypotenuse, so it becomes a upon r. So it is a upon r, so r is equal to a upon cos theta. You can easily understand that this r is equal to a upon cos theta. Now instead of r we write a upon cos theta in this particular equation. Okay, so Pi minus Pu is equal to 2s upon a cos theta you will get. Hence the pressure Pi of the water inside the tube just at the meniscus, that is air water interface, then the atmospheric pressure Po. Okay, so Pi is the pressure inside here, say here at this meniscus, at this particular point the pressure inside is Po, and here the atmospheric pressure will be there and that will be pressure outside. Okay, that is Po. According to the figure, consider 2 points A and B. They must be at the same pressure. Try to understand here. These 2 points, if you consider, okay, A and B, and they are at same height, so their pressure will be same. Okay, the pressure at A is equal to pressure at B. Okay, now pressure at B can be obtained easily. Pressure at B is nothing but this is the pressure which is produced by liquid column, that is rho g h, plus the pressure inside, that is Pi. Okay, so pressure at B is nothing but Pi. Okay, that is pressure at B is nothing but rho g h. Okay, pressure at point B is rho g h plus the pressure which is produced here at point B, that is Pb. Okay, so Pb pressure, okay, Pb pressure is Po plus rho g h, Po plus rho g h, where Po is the pressure outside. So at point B, pressure of on convex surface of meniscus plus the pressure due to liquid column. So try to understand here. The pressure is because of the pressure here, that is pressure outside, plus the pressure due to this liquid column. So it becomes Po plus rho g h. So pressure at B is Po plus rho g h, that is written here. Okay, Po plus rho g h. Now Pa is equal to Pi, where Pi is atmospheric pressure. Okay, so Po plus rho g h is equal to pressure inside, because Pb is nothing but pressure inside. So Pi, or rather we can say Pb is replaced by Pi, so Pi is equal to Po plus rho g h. So Pi minus Po is rho g h. Now instead of Pi minus Po, we can write rho g h. Okay, Pi minus Po na badle we can write rho g h. Okay, so just we place that value, rho g h is equal to 2s cos theta upon A it becomes. Okay, rho g h is equal to 2s cos theta upon A. So h is equal to 2s cos theta upon A rho g. As the radius A is small, the height of column will be more. If meniscus is convex, means cos theta is negative. Okay, liquid depressed in the capillary, or if the cos theta is negative, we can say the meniscus will be a convex meniscus. Here instead of this kind of meniscus, okay, the meniscus will be like this, because the angle theta is an obtuse angle. Okay, thank you very much. Here the chapter is over.